Here is a very simple approach to find the formula for integration of tan x, cot x, secant x, and cosecant x. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are considering a very important integration, and that is integration for tan x, cotangent x, secant x, and cosecant x. Now, all these integrands involve the solution as natural log, and many times students find it difficult to answer questions related to tan, cotangent, secant, and cosecant integrations. We are going to take many examples related with them, but before that, let me prove or find the formula for integration of these trigonometric functions. Well, in case you want to learn directly from me, send an email to globalmathinstitute at gmail.com. Here are four very important proofs which we are going to do, and these will be your formula for integration, and we are going to use them extensively in the coming videos. So the very first one is integral of tan x dx is minus ln cos x plus c. Ln is log to the base e. Now, minus ln cos x can also be written as ln secant x plus c, right? Makes sense. Question 2 is to prove that integral of cotangent x dx is ln sin x plus c. The integral of secant x dx is ln secant x plus tan x plus c. And integral of cosecant x dx is ln cosecant x minus cotangent x plus c. So we'll look into their proof one by one. Make a note of these formulae first. Let me also thank all the viewers and subscribers for watching our videos and posting these excellent comments. We have tried to answer your questions. You have provided us with the suggestions, and so it is partly your own channel. Support your channel. You know, we are reaching millions, and there are many students worldwide who do not get quality education. It is expensive, and we provide it absolutely free for last 15 years with 17,000 more videos, right? And these videos are being watched over 80 countries. So it makes sense to help us reach millions. Now, let's look into the proof which we have. And proof, by the way, gives you a hint of how do we approach such questions, right? The concept which we are going to follow is something like this. We have seen that each and every integration involved a result in natural log. And when does that happen? It only happens when we have a function in the denominator and we have its derivative in the numerator. And by using substitution, we can get a result. Let's say we do the u substitution, u equals to f of x. In that case, what is du? Well, du is f derivative of x dx, right? So you can make this substitution and write integral of f of x over f of x dx as equal to what? Well, is equal to 1 over u du, correct? Simple. And definitely this integral is ln u and the absolute value of u plus c. Make sense, right? So that is the basic for all the four proofs. You get the idea. So once again, here are the four things which we are going to prove, but the pattern of proof is exactly what I shared with you. You get the idea, right? So we'll substitute u as the denominator, right? And then We know that the numerator is only du, and therefore the integral will be of this ln u plus c. That is the concept. Now let's begin with the very first term, which is we need to find the integral of tan x dx. We need to prove rather that this is minus ln cos x. Clearly, cos x should be in the denominator. So we know what tan x is. It is sin x over cos x, right? Dx, correct? Now let's make the substitution, which is u equals to cos x. So du is minus of sin x dx, correct? So let's replace. So we have integral of 1 over cos x is 1 over u, correct? And sin x dx is du minus. Do you see that negative sign? And therefore, we get the result as minus ln absolute value of u, correct, plus c. And we replace u with substitution, which is cos x. Makes sense. So we have done the first proof. So simple as that, correct? Easy to remember also, tan x is sine over cos, and therefore it is minus ln cos x, correct? Well, we also wrote it in a different way, and that was it is also equal to ln sine x, right? Makes sense, right? So, which I will do like this. We'll begin with minus ln absolute value of cos x, correct? Plus c, right? So, this is equal to ln and cos x to the power of minus 1 plus c. And 1 over cos x, as you know, is what, right? 1 over cos x is secant x, right? And therefore, we get our result, which is ln absolute value of secant x plus c. Right? So it could be written in either form, right? So I hope this is absolutely clear. Let's move on and take the next one. Well, in case you like my approach, you can always like and subscribe to our videos, and you can always send an email to me to learn directly. Most of our students are right there on the top doing the best, right? Perfect. Let's move on to cotangent x. Now you have understood the logic behind. So integral of cot x will be what? Well, clearly I will write this as cos x over sin x, right? Dx, and now substitution should be the denominator should be u, right? Which is sin x. And du will be cos x dx. And therefore, I could rewrite this as integral of cos x dx is du, right? And 1 over sin x is 1 over u. And therefore, I could write this as ln absolute value of u plus c, and we know what u is. U is sin x, so absolute value of sin x. Remember, ln is only for positive values, right? The domain is x greater than 0, right? Therefore, we write positive value. Sin x could be between plus and minus 1. So remember that part, okay? So everything here is very important, so you cannot really ignore it. Perfect. So these were very simple ones, but when it comes to secant and cosecant, it is slightly tricky. Well, let's look into what do we need to prove. So integral of secant x is ln of this, right? That means I need secant x plus tan x in the denominator. Only then I can get that result. Makes sense, right? So let me rewrite the question. We want to find integral of secant x dx, right? So what we are going to do is we are going to multiply and divide by what we need, which is secant x plus tan x. You get the idea, right? Perfect. So we multiplied and divide by secant x plus tan x. Now clearly we'll do the substitution u as equal to secant x plus tan x, which is the denominator. Is that clear to you? So du is the derivative of this. Derivative of secant x is secant x tan x. And that of tan x is secant square x dx. Makes sense. Once we know this derivative, we can now see that the numerator is Well, this was secant x, not sine. Let me write this secant x, right? So the numerator was secant x times secant x plus tan x dx. You see that? So you can see secant x multiplied by secant x will give us secant square x, and then we have secant tan x. Clear, right? And therefore, we can rewrite the integral as integral of secant 1 over u du, right? Since we know that secant x tan x is u, right? And their product in dx is du, right? So that is what it is, and that is equal to ln u plus c, absolute value of u, and that gives us ln absolute value of secant x plus tan x. Make sense? Plus c. So that is how we are actually going to get this result. I hope this makes sense, right? Now let's look into the last one, which is cosecant x. And in case of cosecant x, what will you do? You're looking for cosecant x minus cotangent x. And therefore, what are you going to do? So you're going to rewrite cosecant x dx as equal to integral of cosecant x times cosecant x minus cot x divided by cosecant x minus cot x, correct? Dx. And you're going to make a substitution, which is u equals to denominator, which is cosecant x minus cot x, and du will be what? The derivative of cosecant x, which is minus cosecant x into cot x plus cosecant square x, right? Let me write like this dx. So you can see that we can rewrite the numerator, which is cosecant x times cosecant x minus cot x. I could actually factor out this, right? And then rewrite it, correct? So when I factor this out, cosecant x, right? So I can write cosecant x factored out, rearrange, I get cosecant x minus cot x dx. Makes sense, right? So now I can write the integral of 1 over u du, perfect, which is definitely equal to, let's change the ink, ln absolute value of u plus c, which is ln absolute value of cosecant x minus cot x plus c. Do you see that? So we have actually proven all the four with a simple strategy, and that was identify that numerator is the derivative of the denominator. Do the substitution, right? And once you do the substitution, you get your result, right? So that is how you're going to do it. And most important are these formulae which help you solve difficult questions, right? So now get ready for checking some beautiful questions based on the formula we just derived. I hope you like my approach for this particular video, and I hope it really helps. Feel free to support us, and if you can donate so that we can reach millions over a period of time, it all costs money, right? So if you can donate, please do. Thanks for your time and contributions. Thank you, and all the best.